Example 14.1c gives us the equation h of x equals x cubed minus 2x squared plus x. And this is a degree 3 polynomial. It's in standard form, not factored form. And we spent time in section 13 talking about factoring of polynomials, and we did that because we wanted to be able to calculate the zeros. So that was just some of the legwork that we needed, some of the foundational things that we needed in order for us to get to the point where we can talk about zeros, which ultimately will lead us to x-intercepts, which will allow us to be able to graph. So all of the stuff that we've been doing about polynomials is leading to the point where we can graph. So really neat how all this stuff is going to be coming together. So if it's not in factored form, your equation that is, you need to get it there as quickly as possible so that way you can find your zeros effectively. So the first thing I notice here is a GCF, x times x squared minus 2x plus 1. And then that trinomial will also factor into x minus 1 times x minus 1. So if you prefer, you can always write that as x minus 1 squared. And then I need to let h of x be equal to 0, which is how I calculate the zeros. Then I would end up with the statement 0 equals x times x minus 1 squared. I can take any significant factor here involving a variable, and I need to set them to 0, so that would be x is equal to 0, or x minus 1 is equal to 0. The first setting equal to 0 tells me exactly what I'm working with x. X is going to be 0. And then the next one tells me that x could be equal to 1. So stating the conclusion here, x equals 0 has multiplicity of just 1. There's just x to the first power there, so it's just 1. However, x equals 1, that particular 0 has a multiplicity of 2.